Hey guys, this is Dan Amouncy, aka Dr. D, your host. And we are here with a good friend of mine, Don Pensack. And Don Pensack and I go a long way back to the old days of Mount Pinos, where I met Don. I remember Don was in a little cubby hole with this 8-inch Schmidt-Cassegrain LX200 by Meade. And he had this cubicle, so to speak, like PVC pipe and a blue tarp. I think it was blue.
No, they were black tarps.
It was black tarp.
Yeah.
Blue would ruin your night vision.
Opaque. They were opaque to light.
So it's great to have you here. And we never really sat down and talked on camera for people.
Yeah, well.
And you know, you're like one of the hardcore, I think you said that Alvin Huey was probably the only one that's probably seen, well, not the only one, but one of the few people that has probably seen more objects. So he just uses these big aperture scopes, right?
Well, there are people like Jimmy Lowry and the late Barbara Wilson and a lot of people like that who actually have a lot more experience in that regard. I think today one of the finest guys is Steve Gottlieb.
Yeah.
Who basically has observed everything I've observed and probably 100,000 more
things
on top of that. So.
And how much aperture is he using?
I think.
In all fairness, because
he's using something in the 20s.
Yeah, bigger scope.
Yeah.
Remember, folks, the bigger the scope, the more light you collect, the easier it is to see. But we have been known to crack jokes about Don seeing galaxies in daylight with his trained vision.
You see a lot more objects with bigger scopes.
Yeah, you do, exactly. Which is kind of ironic to me because you're so obsessed with seeing faint objects. It's what I really like about you, is that you have this appreciation for faint things, whereas a lot of people are distracted by that. You are not. You're just at the opposite end of the spectrum, and I like that. It's fascinating.
One of the things I've really enjoyed doing recently is galaxy clusters.
Yes.
And
Able clusters, for example?
Able clusters, and a lot of them have 2 or 3 bright members and then a whole host of very, very faint members.
Right.
And I enjoy going for the little faint ones as well as the brighter ones. So.
And what is it that captivates you? What is it that grabs you? Would you say?
Part of it is to kind of push farther into the universe, to see farther out, galaxies at 1 billion light years, 1.5 billion, 2 billion light years.
What's the farthest object you've seen, would you say, in your 12.5 inch?
Besides
3C273.
Besides the quasar?
Yeah.
1.85 billion light years. I don't remember the name of the galaxy. It was a two mass object.
Is it elliptical? Was it a
type
of gas?
Actually, it wasn't elliptical, but it was at 1.85 billion. That was about magnitude 15.5.
That's incredible.
Yeah.
Absolutely incredible.
Yeah, that was
so at that point, you're looking at a map with actual point sources to determine which point, I'm assuming? Or
yes. For
the angular size is
If
small?
it's a very densely packed field, I usually will print out a chart beforehand that shows the names of all the galaxies that are in the field, so I can identify which ones I can see and which ones I can't.
And you're very particular about dark adapting your eyes, right?
Yeah, it's hard.
I know how very particular.
Well,
like he's very particular about this.
It's really hard to maintain the level of dark adaptation you need in order to see the faintest objects.
Yes.
Because if you look at the sky, even at a dark site, if you look at the sky, for a few seconds, you lose that level of dark adaptation.
Oh, yeah.
And then it takes you 5, 10, 15 minutes to gain it back.
Yeah.
And so one of the things I do is you put like a black eyepiece cap on a black cloth on the ground.
Yes.
And you stare at the cloth until you can tell where the eyepiece cap is, and you can reach over and just pick it up. Right. And then you immediately go to the eyepiece without looking at the sky, without turning on a light, and look through the eyepiece, and you will see easily a half a magnitude fainter that way.
Have you measured, just out of curiosity, because I did this once, I was shocked to find out that one of my pupils measured in darkness after about 30 minutes, 7 millimeters, and the other one was 3, which is really a trip.
And that's unusual.
Yeah.
That's
this is many years ago, so I don't know now, but...
were you taking any drugs at the time? Because, drugs do interfere with that.
It's weird. I don't know what was going on with that. It was oddball. But one of the people I know worked at this place where they did LASIK surgery, and they put me in this room for a while, and they did a measurement on it. So it was kind of. Do you have any idea what your? I remember you used to have this little device at Pinos that you used to bring.
Yeah.
Remember that little exit pupil guide thing?
The only problem with that exit pupil guide I discovered is that when you look at the sky, because the sky is brighter than the field in the telescope.
Yes.
Your pupil shrinks.
Oh, yeah.
And so when you have to have some kind of background light in order to use the pupil gauge to decide how big your pupil is.
So you can't get a valid...
You can't get a valid reading. So I always just kind of fudge and add a 0.5 millimeter to whatever the thing determines your pupil is to figure out approximately what your pupil is. Now you could do it. What some friends of mine have done is to hold a millimeter ruler right up to the eye, look in a mirror in a dark room, and use a flash in your camera to take it to take an instant shot. Your pupil will immediately shrink after the flash goes off, but the reaction time of your eye is too slow in order to shrink dramatically. So that way you can get an actual measurement.
Now, speaking of eyepieces, because you mentioned that, where does that fall into your? What kind of eyepieces do you use normally? I think I know, but I think your audience wants to know.
Well.
And you like
before I started wearing glasses at the telescope, because I wear glasses at the telescope now, I was using a full set of TeleVue Ethos eyepieces.
Yeah, I used to.
And TeleVue 31 millimeter Nagler as the low power, and then from 21 to 3.7 on the TeleVue Ethos range.
Right.
But unfortunately, I had to get rid of all of those.
Delos probably.
Down to 6 millimeters. From 6 millimeters down, I can just take my glasses off, and there's no difference in my vision. So
we're talking about astigmatism.
Astigmatism.
Okay.
That's the only reason to wear glasses. Otherwise, if you're nearsighted or farsighted, you can just refocus the telescope.
Exactly.
So, at any rate, so I started experimenting with eyepieces that had enough eye relief for glasses: the TeleVue Delos, the Pentax XW, the Botter Morpheus, and
a lot of eye relief.
Eyepieces that have long eye reliefs, and that you can use your glasses with and still see the whole field of view. And I found that I actually preferred the Botter Morpheus over the others, so I ended up buying a complete set of them.
Out of curiosity, why is that?
Well,
they're not actually quite nice. Bill P likes them.
A couple reasons. One was that I compared them with a number of eyepieces, and they seem to go just a little bit deeper.
So a little bit more light throughput, so to speak.
A little bit more light throughput, or maybe it's the spectrum of transmission to the eyepiece. Whatever it is, the point was that faint tidal tail extensions on galaxies were more visible in the Morpheus than they were in the other brands.
Now, from your perception, does it look more neutral than, say, any other eyepiece in fidelity? Or?
I'm not a person to talk about neutrality. I mean, many years ago, I used to do this test where I would get my refractor out, I would look at a white building, put an eyepiece in, look at the white building, look through the eyepiece, look at the white building, look through the eyepiece, and see if I could see a tint difference between looking at the building and the eyepiece.
Of course.
I haven't done that with eyepieces.
That's great, though, because then you don't have to think. You don't think about it or worry about it.
No, well, the point is that there's a process called normalization, where if you take a look at, say, cream-colored white or ivory-colored white, and you just look at that for a while, it's just white. Your brain automatically compensates for it, and there's no real major difference. Now, I guess an eyepiece could theoretically be tinted so much that it would have an effect in terms of contrast, like on a planet or the moon or something. But I haven't noticed that really, to be honest, in my own personal use. For me, the best planetary eyepiece is the eyepiece that happens to be in the focuser when the seeing is perfect.
Yes, I know.
Yeah.
I can speak from experience. That is very true.
When the seeing is perfect, it doesn't. It really doesn't matter what eyepiece is there. But
that's great, because I didn't know you were using the Morpheus. But when did that? Was that a recent change?
A couple years back.
When you had to start wearing glasses
I had to start wearing glasses, and I have an APM 30 millimeter as the low power, and I have a TeleVue Apollo right in the middle of the range. Yeah, I was one of the ones.
How is it visually? I spent very little time with it. I did, but not as much time.
Just as a note, there is no perfect eyepiece.
Of course.
And it's not perfect either.
Of course, yeah.
But it's the best eyepiece TeleVue ever made.
Oh, interesting.
Yeah.
And why is that? Out of curiosity, what are your...
contrast, sharpness, width of field, ease of use, glasses or no glasses.
Right.
It's just
all around perfect.
All around, yeah, as close to perfect as they've made.
Yeah.
Yeah.
Wow. Incredible.
Yeah. Although the 6mm ethos comes pretty close.
Yeah, it does.
Yeah, yeah.
It does. Now, what's your favorite wide field for like, say you want to see a wide field in your 12.5-inch dom? And why would you use that particular eyepiece, say, over something else?
Well, generally when I'm looking for objects,
yeah,
I have a pointing computer on my scope.
Yes.
So I don't necessarily need to go down to the lowest power in order to find something.
That's the Astro Devices, DSC.
Right, right.
Okay.
And rather than switch to a higher power eyepiece once I found the object. I can actually use a medium power eyepiece that I want to use to look at the object, and I can actually find the object with that eyepiece in focuser. So,
and what objects do you like in particular? Or is it galaxies in particular, planetary nebula, or do they all fascinate you, or is it just...
Virtually everything is fascinating. There will be nights where I spend almost the entire night on open clusters.
Yeah.
There'll be another night where I spend the entire night on galaxies and never look at anything else.
Right.
Or a mix of planetary nebulas and galaxies. But basically galaxies and planetary nebulas, globular clusters.
Right.
Globular clusters in other galaxies too. Maybe H2 regions in other galaxies.
Right. What filters are you using currently for H2s? You know, I know you've been through a lot of filters that you mess with.
It's true.
Remember back in the old day it was Lumicon and, you know, Sky Glows, but yeah.
About 4 years ago, I decided that I was just going to find the optimum filters.
Yes.
For me and my scopes.
Right.
And so I bought 60 filters, had them all tested by a friend who tested them all in the lab with a spectrophotometer.
Oh, fantastic.
So I had the complete spectrum of what would the transmission with percentages at every nanometer.
Yeah.
From 200 nanometers to 1,000 nanometers. So they were all tested professionally. And then I took them out to the field and started using them and comparing them visually.
Yeah.
And I arranged my scope in such a way that I could change filters merely by reaching in the top of the scope and screwing a filter on.
Oh, okay.
So it was.
So I know that Astrochrome. Remember that thing?
Yeah. That's a filter slide.
Yeah, a slider.
But in my particular case, the coma corrector sticks out 3 millimeters beyond the bottom of the focuser.
Yes.
So I can just reach in and thread a filter directly on the coma corrector.
Oh, wow.
So I don't have to take anything out of the focuser in order to put the filter on. Right. So I started changing filters and doing a lot of evaluation and discovered I'm down to about 13 left now.
Really?
Yeah, I want to whittle it down a little bit.
Which particular ones are they at?
I want to whittle it down a little bit more, but
yeah.
I'm having a hard time doing that.
Yeah.
Well, first there's Astronomic.
Yes.
They're a German-made brand, and they're top-notch.
Do you find that I'm curious.
Yeah.
That the transmission, it's pretty good on them?
Yeah.
Okay.
Generally, all the really good filters have transmission in the, say, 92 to 98% range. So it's they're all very high transmission. But Astronomic, and since Astronomic makes teleview filters also would be in the same
category.
And I also did like certain years of production for Lumicon. Lumicon, as a brand name, has had several different manufacturers through the years of their filters. And their filters that were made from 2005 to about 2012 were fantastic.
Yeah, okay.
And then there have been some recent batches from an American producer from maybe 2018 to 2020 that were also exceptional. But other than that, they varied in quality a bit.
It's interesting because I think what happens in our industry that people don't realize is that either sometimes the supplier doesn't provide it, or maybe there's a change in cost, so it forces the company to change.
That's correct.
Yeah, and it's funny because I remember the old Lumicon filters, and then when the newer ones came out, they had kind of this bluish greenish tinge to all the stars. But it's kind of different. If you recall,
it depends upon the filter, because if the filter happens to be a nebula filter and the only wavelengths that it transmits are in the blue-green, if you have a bright white star that's coming through a filter that only transmits blue-green, you can see a blue-green star. Okay, I mean, that's the way it is. Now, some filters, like there's a company called DGM that makes a filter called the NPB.
We have those.
That filter has a very, very broad
Yeah, I was going to say
transmission
broad.
in the red,
Yes.
and a very, very narrow transmission in the blue-green,
Yes.
which makes the contrast exceptional in the blue-green. But that very broad red transmission means that more red comes through the filter than blue-green.
Yes.
So the stars all appear red.
Right, of course.
And that's logical, but you're not really using a nebula filter to look at stars. You're using a nebula filter to look at the
Emission nebula.
And for emission nebula.
And for
That's
people
correct.
that don't know, emissions are typically things that look red in photographs, and reflections are blue. Now, there's no filters yet that help with the blue nebula.
Well, I wouldn't say no filters that help with that, because there have been some people who've experimented around with filters that had predominantly blue transmission that said that they helped actually in terms of contrast on reflection nebulae.
Right.
Because reflection nebulae tend to be next to very bright, hot stars that transmit most of their energy in ultraviolet, blue, and violet.
Of course.
And so if you have a filter that only lets that wavelength of light through, then you could, and blocks a lot of the other light pollution that comes through, for instance, you might see it better. People have reported that they see some spiral arms and some galaxies better with a blue filter as well. Of course. But in general, the only filter that really helps most deep sky objects is the gasoline filter.
Oh, the gasoline filter.
Yeah, you put it in your car, and then you take your telescope.
Go to a dark sky?
Yeah, right. That's really what helps the most. Yeah.
So now tell me what maps inspired you? Because I know, when we observe at nightfall, you and I, you'll have a desk full of books at some time. Yeah. Now, using computer programs, or I observed with Alvin Huey a couple of times, and he was using this really ultra deep red. He's a fanatic like you, he wants everything like the preserved vision to the max. And he's using this digital screen that's like the faintest thing. Like you need to spend time to darken up your eyes just to look at this thing.
Well, right? For instance, my digital setting circles on my telescope have a small little OLED screen on it. There's 256 levels of brightness. I typically keep it somewhere between 1 and 5.
Oh, wow, that's very dark.
You have to be 4 or 5 inches away from the screen to even tell it's on.
Yeah,
and that's the brightness that I leave. And I have it so that the screen automatically turns off after a minute.
Do you use maps ever? Not now, but I mean, in your past, explain a little bit about
I started out,
what inspired you.
I started out in the 60s with, I started out with the Skulnate Plazo.
Oh, the Skulnate, Plazo. I actually have one at home, but continue.
That was my first atlas that I had, and it was very useful to me. I found, the first summer I observed, I found all the Messier objects. Found a whole bunch of NGCs, and so...
it's funny, because when I look at mine, I'm like, God, there's like nothing in it compared to what we see now, right?
I know. Well,
Frolov catalog, or,
Colin... I know, there's maybe, 1,000 objects in the whole...
Probably, it's very limited. But continue, I don't want to interrupt you. It's just cool to hear about it.
Later on, quite a few years later, after using that atlas for a long, long time, I got the Tyrion Sky Atlas 2000.
Yeah, everybody did.
Yeah, everybody got that. And I got the large version, the laminated one, the deluxe
colored
one, in colors and color and everything else like that. But the only thing I didn't like about that was that it wasn't immediately obvious to me what constellations were on a page when I flipped the pages.
Of course, because they're not.
So I used a Sharpie and drew in all the lines.
I did the same thing with mine.
Yeah. And I used that for a long time, and then Uranometria came out.
Exactly.
And so I got that, but Uranometria was hard to use because the charts went backwards.
I know, it's kind of weird in that regard. The newer one's a big improvement in that regard.
The second edition, they put the charts in the correct order.
Yes.
Where the right-hand side of the chart went to the next page rather than the reverse page.
It was weird doing it that way.
Yeah. But, and then when they came out with the All Sky edition, which was just in one book, I got that version. That's the one I've been using ever since.
Which one is that again?
They have an All Sky version where the two catalogs have been put into one book.
Exactly.
So and I've been using it ever since. And
now, before
that's about right for a 12.5 inch, because there's about 35,000 objects in deep sky objects in the Atlas, and that's about the limit for a 12.5.
So, but as far as, do you ever find yourself using Uranometria to star hop to a particular galaxy or point out a position of a particular galaxy?
Not anymore.
Not now, of course, but back in the day.
I use the expanded charts at the end.
Yes.
which have, really large scale for like very crowded areas.
Areas, of course.
Yeah.
Okay.
Yeah. I've used a lot of those in the field. I typically will photocopy it and take it to the field with me as a sheet of paper.
Yeah, rather than lugging
the book just to see it one page.
Sifting through 20 pages.
Yeah. And now I use computer atlases most of the time to print
You do
that.
now. Okay, makes sense.
Because my computer atlas goes a lot deeper.
Any particular computer program that you recommend for the audience?
Well, Megastar, which used to cost money, but now it's free.
Yeah.
Is an excellent star charting software. I actually find it easier.
Been around for ages.
It's been out for ages, but it's easier to use than a lot of the newer ones.
Yes.
You know what I mean? And I've got Sky Tools too, which helps me plan my observations because you want to plan your observations so that they flow through the night.
Of course.
So that you don't try looking for something that's not going to be up till 4 a.m. at 10 o'clock at night, Of
course.
So I plan my observations to go through the night. And I'll typically see 50 to 70 objects over the course of a night.
Oh, right. Plus, you might want to avoid a particular light dome that may be in a particular part of the sky.
That's definitely the case with some sites that I've been to where a light dome is so large and so invasive that you just don't want to look at anything in that part of the sky.
Of course. Yeah, I can understand.
Yeah.
Don, thanks so much for being with us. It's so cool to finally have a very experienced deep sky observer on the channel. Because we're always talking about gear, but it's cool to talk to a real veteran observer with over 60 years experience. So it's very impressive. So thanks.
And I want to make one additional point, and that is to the beginner.
Yes.
And that just realize that you will never see less than you see now.
Yeah.
That with experience comes the ability to see deeper and deeper and deeper and deeper. It's like you don't sit down at a piano and play Rachmaninoff piano concerto on your first day, right?
Exactly.
You have to teach your eye how to see things that are right at the limit of your vision, and that automatically happens over the years.
Yeah, exactly.
So the longer you observe, the more you quote unquote practice, the more you'll see. I can't tell you how many people have come back to me after 2 years and said, I first looked at the Messier objects when I got my telescope. They were dim and faint and hard to see. Now I come back to them.
Heard it a million times.
Now I come back to them when I want to see something really bright and detailed. So,
Don, thanks for being with us.
Yeah.
Hey guys, we're going to be back at you soon. Thanks so much for watching. This is Dr. D out.